Hello again. This is Chris Thrawn, Texas A&M University Central Texas, continuing my presentation on epidemiological modeling. And in this video, I'm going to show you how to construct a simple epidemiological model in Excel. This will be a SIR model. Remember that SIR stands for susceptible, infectious, and recovered. So by the end of this presentation, you will be able to make a spreadsheet model like this. I'll go through step by step how to construct this model. I showed in a previous slide the COVID cases in New York City. So this is data that I obtained from the New York City Department of Health website. You can download data like this. So I obtained this data, new cases 7-day average, and then I computed the cumulative cases and divided by 10 so that I could fit both of these curves on the same graph. And here's my COVID cases from Texas. Okay, so if you learn how to use spreadsheets for modeling, you can make your own graphs from public data and show how the disease is changing. Right? So this is data that's taken from real life. I'm going to show you now how you can make a SIR model that will show how the susceptible, infected, and recovered populations change over time. Right. And I will include this spreadsheet in the course materials. So let me show you how to build your own model, and I hope that you will follow along. You can open your own copy of Excel, or if you have LibreOffice, you can use the LibreOffice Calc, which can do the same thing. You can pause the video and type just like I've typed. So, in order to save time, I've typed in the words beforehand. Here I have the parameters that I want. I have initial conditions, which is my total population, and my starting percentages of susceptible, infected, and recovered. And then I have my model parameters, which are mean contacts per day. That's what I called C. And then I have my transmission rate, which I called T. And then I have beta, which was C times T, divided by the total population. Finally, I have my recovery parameters, the mean infectious duration, which I called D, and the recovery rate. And then we'll talk about these later. Let's start out with some parameter values. I'll begin with a total population of 1 million people. For my starting percentages, I'm going to leave this for a moment, and I'll say my infectious should be 1%, and my recovered should be 0%. And my susceptible should be chosen so that the sum of these three numbers is equal to 1. Is equal to 100, rather. So because I need 100% susceptible plus infected plus recovered. So I'm going to write this as equals 100 minus this one minus this one. All right. So I only need to change my infected and recovered parameters in order to get my susceptible. Now I'm going to go here and I'm going to make this box gray to show that it's computed. So I'm going to put a gray here like this. Okay. So this shows me that this one I don't change, it's going to be computed. Now I need my mean contacts per day, which is 10. Okay. My transmission rate, I'll say my transmission rate is 0.06. This is a number for COVID. And then my beta is going to be the product of this number times this number divided by the total population. Okay. So my beta is very small. All right. Now, since I'm going to be using this in my model, I'm going to call this beta. that's going to be used in my calculation of SIR over time. So now let's find the recovery parameters. Let's suppose my mean infectious duration is 5. That would be 5 days. And my recovery rate will be 1 over the mean infectious duration. Okay. And this is what I call gamma. So I'm going to call this cell gamma. Okay. All right, sorry. I call this cell gamma. All right. All right, now let's go ahead and fill in the SIR over time. All right, I'm going to start at day 0. Now the next day is going to be 1 plus the previous day. All right. Now my starting value of susceptible is going to be the total population, which is this, times the susceptible percent divided by 100. Okay, that's the fraction of susceptibles times the total population. So that's my starting number of susceptibles. My starting number of infected is going to be equal to the total population times the percent infected divided by 100. Okay. My recovered is going to be the total population times the starting recovered divided by 100. Okay. All right. So now I need to put in my formulas for S, I, and R. So let's go back and review what these are. The rate from susceptible to infectious is beta SI. The rate from infectious to recovered is gamma I. Okay. So let's put that into my spreadsheet. On day 1, how many susceptibles? Well, I'm going to have the susceptibles from the previous day, but I need to subtract off the number that become infectious. What's the number of infectious? Let's go back and look again. Infectious was beta SI changed from susceptible to infectious. All right. This is going to be equal to my susceptibles minus, I can just type in beta, that's fine. And then times my number of susceptibles from the previous day times my number of infected. Okay, so I have my susceptibles from the previous day minus beta SI. Okay, so that gives me my new susceptibles. So you see the number of susceptibles has reduced. All right, next I need to do my infectious. So how do I get my infectious? Let's go back and see again. Infectious would be the previous infectious plus the susceptibles that become infectious minus the infectious that recover. All right, so let's put that into my equation here. So this is going to be equal to the previous infectious plus, now what are the susceptible that become infectious? Well, just remind you, beta times S times I. So this is going to be equal to beta, which is this value, or let me just type in beta. That's probably better for me to do that. Okay, then times the S value, which is here. It's the S value from the previous day times I. Then I have to subtract those who recover. And those who recover, if you remember from this picture, is gamma times I. Okay, so here I have gamma times the infected. All right, so those are my new infected. Now how about recovered? Well, recovered is going to be the recovered from the previous, then plus gamma times I. All right? So now I have my 3 numbers, SIR, for day 1. To get days after this, I only need to select these cells. Now I like to select by holding down the Shift button and then pressing the arrow key. And then I can press page down to select several pages of cells. All right. Now I want to fill down my formula. So I go to Home, and this button here is Fill Down. And then I do Down. Okay. Now you can see that by the end of my time, after 109 days, I still have 46,000 susceptibles, very few infected, and most are recovered. All right, so let me go back to the top. I'm going to select these columns here, and I'm going to insert a plot. Now the plot I want to insert is called scatter because the first column, days, is plotted against the other three. So let's do this one here. And you can see this very nice curve here for the S, I, and R. And here I can say SIR model here. Okay. Let me move this over to the side. Okay. And you can see. Now I am able to change these numbers here and see what happens to my SIR model. Suppose I increase my number of contacts per day to 15. Here you see the peak becomes sharper and sooner. You can see that almost everyone gets the disease eventually and has recovered. Suppose I reduce my contacts to 5. Now you see the peak is much more spread out, and in fact fewer people become infected. All right. This would correspond to social distancing. All right. I can reduce this even further, and the peak is spread out even more. So once you construct this model, you can explore what will happen to the model if you change your different parameters. So in the next presentation, I will show you how to explain herd immunity, reproduction number, and the flattening the peak using this SIR model. So please take some time to construct this model so that you can follow along with me.